cross sections part 2. What? All right. So find the volume of the solid in which the base is a circle centered at the origin with radius 3 units. So the bottom of my figure is going to be this circle. Please pardon the horrible circle I'm about to draw. Oh, wait, no, I know how to do it with... There we go. Technology. Okay. So that's going to be the base, the bottom of my figure. Okay. This is going to be the bottom of my figure. Okay. All right. They want the volume of the surface whose cross sections are squares. Squares perpendicular to the x-axis. Okay. So let's draw that on my little app. It's going to take me a second or two. Probably should have done this during lunch. But if you guys can't use the bathroom during lunch, I can't type in functions during lunch. Yeah, fair. Okay, that would be what? 9 minus x squared. Oh. Let's try this. 2 the 1 divided by 2. It's going to be what? 9 minus x. There we go. This app is nice, but like the way you put in the functions is terrible. I will say. No. There we go. 1 divided by 2. Okay. 9 minus x squared. And I want to put a negative in front. Negative. Yes. Wait. No. That's gonna be imaginary. Oh my gosh. It's horrible. I did it this morning while I was prepping. I forgot how to do it. No. I hate this. All right. Negative. I got it this morning. I swear I had it this morning. Divided by 2. 9 minus x squared. Yeah. Nothing showing up because that's an imaginary number. All right, let's try this again. Oh, you know what I'll do? This is brilliant. Times negative 1. Boom. Wait, no! Where'd it go? No. Okay. 2 the 1/2. Brooke's not back anyway, so we'll just wait. No. Yes, got it. Good. Okay. Sorry about that. Wait, what's going on? Did I do that wrong? Did I just put in the wrong function? wrong? 9 minus square root of 9 minus x squared, right? There you go. That's also wrong. It should be giving me a whole circle. About ready to give up. Sorry about that, guys. Oh, the interval's wrong. The interval's wrong. It should go from -3 to 3. All right. Hey, what's up, Brooke? We got nothing done while you were gone. Okay, cool. So hard. All right, so let's just pretend that never happened. Okay? All right, that never happened, okay? You got icebreakers again. That's all. I don't want one. Okay, so this is the base. We have a surface, and we're moving on to our surface now. Instead of the base being a little triangle, the base is a circle. So the bottom of our figure is that circle right there. Okay, it's a circle with radius 3. Okay, it goes from -3 to +3. Okay. So I put it into the app after much painful typing. Okay, so here's the bottom in 2 dimensions. Here's the full shape. We want the cross sections to be squares. Weird looking thing right here, right? All right, imagine having one of those in like your desk in your room. Okay. So we want to add up the areas of all the squares, okay? So, right, area of a square is side squared, right? Okay. What's the side? So one side, right? You see I have all these squares right here, like stacked front to back, right? Do you see how the length of the bottom side is just the height, or in this case, the width of the circle, okay? Oh gosh, that might have broken it. I don't think it did. Okay, good. Okay, good, good. So if I turn it, yep, so that's the exact same thing as the height of the circle. You see that? Okay. So how am I going to get the height then? We want the length of each of these stripes here. That's going to be the length of each square's side, the side of each square. Okay, how am I going to get that length? We do the top function minus the bottom function. Okay, so one thing I did not mention is we have, when you're working with circles, this is not a function, right? The circle, the whole circle is not a function, right? You know why it's not a function? It doesn't pass the vertical line test. Okay. So you have to treat it as two different functions, okay? Equation of this circle is x squared plus y squared equals 9. Solve for y, you get y squared equals 9 minus x squared, or y equals plus or minus the square root of 9 minus x squared. So the blue function on top, that's y equals positive square root of 9 minus x squared. The red function on bottom, that's y equals negative square root of 9 minus x squared. All right. Questions, comments, concerns? Okay. Right, the height, the length, right, right, each side is going to be the blue minus the red. Square root of 9 minus x squared minus negative 9 minus x squared. That's just plus positive 9 minus x squared. So it's 2. So each side length is equal to 2 times the square root of 9 minus x squared. Okay. How am I going to get the area then? Going to square that, so it's going to be 4 times 9 minus x squared, which equals 36 minus 4x squared. All right, and then how am I going to get the volume? Yep, I'm going to add up all the areas. So integral from -3 to 3 of 36 minus 4x squared. I never really explained where the -3 and 3 came from. So the left boundary here, that's x equals -3, right, because the radius is 3. The right boundary is +3. Questions, comments, concerns? Okay. So let's do that integral real quick. That's going to be 36x minus 4/3 x cubed, evaluate from -3 to 3. It's going to be 36 times 3 minus 4/3 times 3 cubed. Minus 36 times -3, and then plus, it's a minus minus. 4/3 times -3. Okay. And evaluate the exponents, and you're done. It's 27. It's -27. If you evaluate that all the way, you get 144. How are we feeling about that? Can I move on to the next one? Okay. So now our cross sections are going to be sort of semicircles. Okay. So now it's a dome. Right. Here's our bottom, and here's our little dome here. Okay. What do I need to know to find the area of each of these semicircles? The radius, right? So the radius, right? If I've got a semicircle. I've got all these, no. All right, is it worth it? Is it worth it? Okay, it's not worth it. Okay, so if I've got this little bottom piece right here, right? And like, there's like a semicircle like going behind the TV out of the bottom, okay? The radius of each semicircle is gonna be the length from here to here. That makes sense? So the radius is going to be equal to what? It's just going to be the value of the top function. So the radius is equal to the square root of 9 minus x squared. Okay. What's the area of each of those circular cross sections, or semicircular? So pi r squared over 2, which is pi over 2 times 9 minus x squared. Okay, so then the volume is going to be the integral from 0 to, or -3 to 3 of pi over 2 times 9 minus x squared dx. Okay. So then evaluate your exponents, and that's your answer. Man, that's tragic. That's a tragedy. So mad. Spent all that time in the function. All right, questions, comments, concerns? So the radius, right? The radius of a circle is half the length, right? Half the length across. So each of these up and down stripes, that's the bottom of one of the semicircles. Okay, right? The semicircles are going back behind the TV. Okay, they're curving back behind the TV. So if we did the whole thing, the blue minus the red, that would have been this whole length. That's the diameter. We only want half that. So it's just going to be the length from the x-axis to the function, which is just the value of that function. Does that make sense?
Yep.
All right, cool. Now they're equilateral triangles, okay? All right, I think you guys might be able to do this. Okay, what do you think I'm going to do? What's that? Yeah. So now there's a bunch of equilateral triangles going behind the TV. They're sticking out. Okay. Okay, they're sticking out like this behind the TV. Okay. But all the lengths, all the sides are the same length. Okay. So what's the length of one side of the triangle going to be given by? Yep. So it's just going to be, again, it's going to be 2 times that. 2 times the square root of 9 minus x squared. So s equals, there we go. And the area of each one is going to be root 3 over 4 times s squared. Cancel. Volume equals root 3 times the integral from -3 to 3. 9 minus x squared dx. Okay. Notice we have that integral right here. Okay. So our answer is going to be this value right here, which we just found. But instead of having a pi over 2 in front, we just have root 3. Questions, comments, concerns? Guys, okay if I move on? Okay. So for D, now the cross sections, so these little red stripes, these are the hypotenuse of an isosceles right triangle. Okay? It's an isosceles right triangle, okay? So now there's a bunch of triangles sticking back behind they're pointing back behind the TV, right? This is the bottom side, the hypotenuse of each of them. Okay? So the hypotenuse length is going to be given by what? Yeah, these are the hypotenuse.
So is it 2 square root of
Yep. Okay. How do we go from, in an isosceles right triangle, how do we go from the hypotenuse to the legs? How do we find that length? You know what you say? I appreciate the honesty. How do you? So if we know the length of the hypotenuse of this triangle, it's an isosceles right triangle. How do we go? How do we find the length of a leg then, knowing that? Someone forgot their special right triangles.
Divided by 2?
Who said that? You're really close.
Root 2?
Yeah. So to go from hypotenuse length to leg length, you divide by root 2. So the length of each leg is going to be 2 over root 2 times the square root of 9 minus x squared. Okay. And then what is the area for the, what's the formula for the area of a triangle, a right triangle like this? Yeah, 1/2 base times height, right? So the area of each is going to be 1/2 times 2 over root 2, root 9 minus x squared times 2 over root 2, root 9 minus x squared, okay? It's going to equal, these are going to cancel, these 2's. So we'll get 2 over 2 times 9 minus x squared, which is just 9 minus x squared. Okay. Okay. And then the volume, right? So this is going to be the area of each of the triangles that makes up our surface. Right? To find the volume of the surface, we add up all the areas. So we're going to do integral -3 to 3 of 9 minus x squared dx, which we've done like now for the third time. We've already done that integral. What did we say that was? That's 9 times 3 minus 1/3 times 27. Man, I'm milking the 4 function. Minus 9 times -3 plus 1/3 times -27.
It's better be what we have to do it on the
I think this is really bothers me. I have to do this out. He said what, Jake?
That's better be the way we have to do it on the AD exam.
You don't have. You can always just do it out all the way.
I know, but if College Board like changed it where you always have to do it out.
Yeah, let me double check. I'm fairly certain.
I don't
Like
know
100%
why-
sure.
I don't know why they would change it, but it's College
36.
Board.
Evaluates at 36. Yeah, it's college board, so they want to ruin your life by any way possible. I remember that company. Oh, you want us to like send an email to a school to tell them what you got in the SAT that you paid $200 for? That'll be $50. It's a genius business model, though. It's like, wait, you want me to like tell your parent? Like that's like me saying like, if you want me to tell your parent what your grade is, that'll be $50. It's like so absurd. So absurd. All right. Wait, so yeah, we got the answer. That was 36. All right. I showed the work on the board. Probably can't see the board on the laptop, but oh well. The cross section this cross section is perpendicular to the x-axis are isosceles right triangles with a leg residing along the base, okay? So now these little red stripes here, these are the legs of a right triangle, okay? So you've got like, here's a leg, right? So like here's a leg, and then the other leg is gonna go back behind the TV, and the hypotenuse is gonna come back up to the top of the circle, okay? So what's the length of the leg gonna be then? 2 times root 9 minus x squared, yep. How do we go from leg to hypotenuse? Root 2, yeah. So now it's going to be 2 root 2. 2 root 2, root 9 minus x squared. Okay. We actually didn't need that hypotenuse, did we? I'm not even going to use that. Okay, so now our area formula. One half times base times height. Okay, these cancel. 2 times 9 minus x squared. Okay, that integral. Right, this is going to be 2 times the integral that we've found like 4 different times now. So it's going to be 2 times 36. Yeah, 2 times 36. Don't do, just in case you mess it up, don't do it. Don't evaluate it. Questions, comments, concerns? How we feeling?
Alright.
Can you give one of these to everyone? So I'm giving you a little notes chart. I was told I should give you a copy of that chart. Can you give a homework to everyone?